So we have practiced some numerical problem in the previous class, and due to some issue it got disconnected. Now continuing that, we will have three different scalar equations, and this is the three vector p, vector q, and vector 2 vector fields, and we have to evaluate its uh, curl. So curl. So from the equation, we can see that the P is in Cartesian, Q is in cylindrical, and T is in phi. So we have to evaluate these integrals in all the other three coordinate systems. So performing this one by one, we have, so taking option A, so del cross P. So del cross P can be written as del upon del x square yz ax, sorry, we have to find curl, so I'm taking first one. So this is ax, ay, and az. So we have to find its del upon del x, del upon del y, and del upon del z. So we have equations x square y z, and y component is 0 and x z. So it will give, expanding it, so it will give del upon del y x z minus del upon del z 0 ax. So we have, this will 0 minus 0, so ax component is 0. Now for the second component, y component, so minus sign, del upon del x xz minus del upon del z x square yz. So this is y component, del upon del z x square yz. So evaluating this, we get z, and this will give x square y minus time, that is x square y minus z. Now the third term, expanding it, the third term, we have del upon del x 0 minus del upon del y x square yz. This is the third az term. So this will give 0, and this is minus x square z az. So it definitely give, so the del cross P is equal to x square y minus z ay minus x square z. So this is the final answer. This is the final answer. Now we will evaluate this integration. So for cylindrical, so that is taking question B. So question B is Q rho sin phi a rho rho sin phi a rho plus rho square z a phi rho square z a phi plus z cos phi a z. So this is the term. So we del cross Q in cylindrical. We have 1 upon rho a rho rho a phi a z, then del upon del rho del upon del phi del upon del z, and we have rho sin phi, this is rho square z, and this is z cos phi, and we have to multiply this phi term with rho. So rho again multiply with this all term. So expanding this with respect to a rho, a phi, and unit vector a rho, a phi, and a z, we have. So first with respect to a rho, so del upon del rho rho square z and also we have a 1 by rho term. So del upon del rho, sorry, we have to evaluate it when the respect del upon del phi. So del upon del phi, and this will definitely, so del upon del phi z cos phi minus del upon del z rho cube z. So it will give it will give so phi, so cos phi minus z, so minus z sin phi, and it will give minus rho cube. So the first term is um, minus z by rho sin phi minus rho square a rho. So this is the first term of the curl. Now the second term. So we have this term. So del upon del rho z cos phi minus del upon del z rho sin phi. Del upon del z rho sin del upon del rho z cos phi del upon del z rho sin phi. Rho sin phi. Evaluating this into differentiation we have. So rho, this is rho, so it will 0 minus and result is 0. So the phi component is 0. So we have 0 into a phi. So phi component is 0. So we don't have the phi component. Now the third one, expanding it with respect to az. So del upon del rho rho cube z, del upon del rho del upon del rho rho cube z and minus del upon del phi rho sin phi. So del upon del phi rho sin phi for az term. So evaluating this differentiation, we have 3 rho square z minus rho cos phi, and of course 1 by rho. So it will have, this will give 3 rho z minus cos phi. So this is the third term. So the final curl of a vector q is minus z by rho sin phi minus rho square a rho plus 3 rho z minus cos phi az. This is the answer. Now the last C option, last question, the C question. This equation is in spherical. So this is in spherical, 1 upon r square cos theta r. So 1 upon r square cos theta a r plus r sin theta cos phi, r sin theta cos phi and cos theta. He must ensure that you have rightly written the notation of the theta and phi. If you make this a little bit mistake, this will definitely give you wrong answer. So del cross, this is, I think this is t. So T del cross T is equal to 1 upon r square sine theta. So A r a theta r square sine theta a phi. Now del upon del r, del upon del theta, del upon del phi, r theta phi. So first equation is 1 upon r square cos theta. Second word is r sine theta cos phi. The third one is cos theta. So evaluating with respect to unit vector ax, theta and r square and a phi we have. So first taking ar and this term r square sine theta. We have del upon del theta cos theta minus del upon del phi 1 upon r sine theta cos phi. So evaluating this we have so minus sine theta and so cos minus plus, so this is r sine theta sine phi. So rearranging the term we have so sine theta get cancelled out. So this sine and this sine get cancelled out. We have only 1 upon r square r sine phi minus 1 ar. So this is the first equation of the spherical one. We have evaluated the AR term. I think something is not let cross checking the 1 upon r square cos theta, r sine theta cos phi and cos theta. So I have expanded AR term, so verifying it once again. So del upon del theta cos theta. So we have a del upon del theta. Okay, I got it. So here what we have mistaken, we have forgotten the scaling factors. We have written here, but we have forgotten in the below part. So we have the scaling factor here r and here r square sine theta. So this must be ensured that you are not forgetting the scaling factor. So you will finally get the wrong answer. So again, reevaluating this, we have AR R square sine theta. Now taking the differentiation by having a scaling factor with them, so del upon del theta, this will give R square sine theta cos theta. So this is R square. So T phi term is sine theta. So R square sine theta cos theta. This will R. This is and this is R, and this is also R. So this term will be not here. So R sine theta cos theta. Okay. So R sine theta cos theta. So this is the biggest. This term's scaling factor must be there, and this integration is very big. So we have to pay attention on each and every terms that we have written the scaling factor or not, we have correctly multiplied the scaling factor with the unit vector or not, we have correctly multiplying the scaling factor with the different vector terms with the different terms of the given vectors. So first you have to ensure this, then you have to differentiate it with respect to theta, r theta and phi. So r sine theta, so del upon del theta, r sine theta cos theta minus del upon del phi, so r square sine theta cos phi. Okay, so we have ar r square sine theta. So the we can write it sine theta cos theta. So 1 by 2 sine 2 theta. So 1 by 2 sine 2 theta minus del upon del phi. We can evaluate this. So phi cos phi minus plus. So r square sine theta sine phi. So finally we have vector ar upon r square sine theta and sine 2 theta will give 2 sine cos 2 theta. So 2 to get cancelled out, we have r cos 2 theta. So r cos 2 theta plus r square sine theta sine phi. I think it's correct. So we will have the final rearranging the term we have. It will give finally it will give cos 2 theta upon r sine theta. One r get cancelled out plus sine phi. Yeah. So this is the first term. R square sine theta cancel out. r square, this sin phi and 1r cancel out, cos theta upon sin theta. Now the second term. The second term will, first writing a scaling factor is very much important, and the sign of the matrix. So minus r a theta. Now we expanding this. So I have written the scaling factor with, now we expand the del upon del r sin theta cos theta minus del upon del phi 1 upon r square cos theta. Cos theta. So this is 0 and this will give, so r sin theta cos theta. So we have minus r sin theta cos theta a theta. And this term is also there. So we have cos theta a theta. This is the second. Now third one. In the third we have r sin theta phi and the factor this out of the matrix factor, and this factor which is out of the matrix. So del upon del r square sin theta cos phi minus del upon del theta one upon r square cos theta. So evaluating this, we get 2 r sin theta cos phi minus, and this will get plus, so sin theta on r square, and we have this term, this theta get cancelled out, this r get cancelled out, so we have phi 1 by r. So final answer will be, so final, I am writing the final answer. So del cross t is equal to, final answer is cos 2 theta upon sin theta minus sin phi, plus sin phi here, and this is minus cos theta upon r a theta plus this is So taking sine theta common, so this is, and r, so this is 2 cos phi plus 1 upon r cube sine theta. So this complete equation for spherical vector field T, curl of this is vector field T in spherical. So thank you students. We will continue our class by some more numerical problem on Stokes theorems, and then we will finally study what is Laplacian of any scalar field in all the three orthogonal coordinate systems. So thank you for today.